During the oil production process, produced water returns to the surface along with the produced oil. The management and disposal of this produced water is a significant challenge, especially in formations with high water-to-oil cuts. Historically, this produced water was considered a waste product and was disposed via deep water disposal wells, which is costly and energy-intensive. However, this produced water also presents an exceptional opportunity. If properly treated, this water could be put to beneficial reuse in a variety of applications. Today, WaterTectonics Middle East is developing an innovative system to do just that: capture, treat and reuse produced water for agricultural irrigation, thus transforming a waste product into a sustainable and valuable resource. Produced water contains varying amounts of suspended and dissolved solids, emulsified oils, metals, bacteria and sulfides. In conventional treatment systems, the variability in these constituents made operating costs difficult to manage and systems were ultimately unviable. WaterTectonics Middle East's new system is designed to reduce over 99% of these contaminants and achieves 90% recovery of the final effluent water through this innovative design. A full-scale 20,000 cubic meter per day treatment facility would have a total footprint of approximately 2 football pitches. Let's see how it works. The water treatment facility consists of a 6-stage system that includes electrocoagulation, induced air flotation, multimedia filtration, ultrafiltration and a 2-stage reverse osmosis system. Key to this process is the electrocoagulation system, which provides superior pre-treatment of the water, enabling cost-effective and efficient implementation of all the other downstream processes. The electrocoagulation or EC system consists of 3 primary components: a power supply, the EC cell housing and the EC electrodes, in this case metal plates. As water passes through the EC cell, multiple reactions take place simultaneously. First, on the surface of the anode, a metal ion is driven into the water. Second, on the surface of the cathode, water is hydrolyzed into hydrogen gas and hydroxyl groups. And third, electrons flow freely from the cathode to the anode, which destabilizes surface charges on suspended solids and emulsified oils. As the reaction begins, metal ions complex with hydroxyl groups and form large flocks that include metals and other contaminants. Suspended solids and emulsified oils are readily entrained within the flock because of the destabilized surface charges. And finally, the hydrogen gas bubbles help to separate and lift the flocks. These cooperative reactions are what makes the EC process so effective and efficient. As water enters the induced air flotation or IAF system, the effects of the EC reaction are further accelerated. Gas bubbles are generated by a small air pump, which helps lift the EC flocks to the surface of the IAF tank. Approximately 70 to 90% of this sludge is removed by an automated skimmer. The remaining 10 to 30% of the sludge settles onto incline plates and rolls down to hoppers in the base of the IAF system. At this point, 80 to 90% of the non-saline contaminants have been removed. As water enters the multimedia filtration or MMF system, it flows down through a bed of glass media. Particles larger than 15 microns are trapped on the top of the bed as effluent water exits the filter at the bottom. The MMF system is periodically backwashed to the source tank to reduce operator maintenance. As water enters the ultrafiltration or UF system, it is dispersed through a manifold of UF membranes. Suspended solids and other contaminants are filtered out at the membrane fiber outer core. As contaminants build up on the outer core, a cleaning cycle is activated which utilizes pressurized air and backflushing with treated water to keep the UF membranes clean. At this point, 99% of the non-saline contaminants have been removed. As water enters the reverse osmosis or RO system, it is dispersed through a manifold of RO membranes. Water in the product channel is recovered as final effluent, and water that cannot pass through the RO membrane is sent to the reject recovery reverse osmosis system. The recovered final effluent from the reject recovery reverse osmosis system is combined with the recovered water from the reverse osmosis system, ultimately resulting in 90% produced water recovery through the plant. Additionally, the water now exceeds all agricultural requirements. The water could be used to irrigate agricultural crops such as groves of date palms, which would create thriving agricultural and socio-economic growth where little existed before. Further, the small footprint and simple design of this model make it easy to repeat across the oil and gas fields of the Middle East. To learn more about this system or any of our other water treatment solutions, please visit our website or contact us using the information provided below.